All right, welcome Math A Honors to lesson 5.2c. We're going again over proportionality, which goes through tables, context, graphs, and the first three are review. How is a proportional relationship represented on a table of values? So remember, in a table, you have maybe an X and a Y. You have two different variables. They might be lined up in rows. They might be lined up in columns, whichever. And you have some values. Okay. And if it is proportional, I know that one, on my situation, it's column, could be rows, is a multiple of the other. So here I see that every time I want to get to Y, I'm multiplying by 2. So here the dependent values are a multiple of the independent values. Remember, typically the Y is the dependent and the X is the independent. Okay, if I'm graphing and it is proportional, I am going to see a line through the origin. Okay, so whatever steepness, but it goes through the origin. On an equation, so the equation for the one I made up is y is equal to 2x. There's only multiplication. Now remember that if you divide, that's really just multiplying by a fraction, so that would count too. But there's nothing added to the end. Nothing added to the end means that we're starting at 0, 0, which means we go through the origin. Okay? So for the table, the dependent values are a multiple of the independent values. For the graph, it's a line through the origin. For the equation, there's only multiplication. There's no added or subtracted constant. There's nothing at the end. Okay, again, you can pause the video right now and catch up your first three. You have the ability to pause when you need to catch up or rewind, whatever you need to do. So those are the review things. That's what we went over in lesson 5.2b. And now we are moving on. Now we have a context. Tony ran a marathon. The graph given represents the distance she traveled over the course of the race. So I'm looking. This is my independent. I can't control time. This is my independent. I looked at the scale, 0, 1, 2, 3, 4, 5, 6. So I put 0, 1, 2, 3, 4. Could have put 5, 6, kept going if I wanted. I don't have to be in any particular order. My dependent is my miles. I have to look at where it kind of hits. 1 is hitting at 6. And 2 is hitting at 12. And 3 is hitting at 18. And 4 is hitting at 24, and 5 is hitting at 30. So I put some of my points in. Now, looking at the graph, I know it's proportional because there's a line through the origin. Looking at my table of values, I know it's proportional because if I multiply by 6, I get all my miles, always multiplying by 6. So is the relationship between time, distance, proportional related? Yes. How do I know? Well, in my table, to get to my miles, I'm multiplying by 6. In my graph, I see I have a line through the origin. Okay, hit pause, catch up. Because we know it's proportional, we can make an equation. So I kind of did that up here. Miles is equal to 6 times time. Miles equals 6t. It asks us to show your equation works by choosing a point in table A and verifying it. So I am checking my point 318. I could have checked 424 or 212 or 16, whichever point I wanted. And I'm plugging it into my equation. So my m is the 18. I've got the 6. That's my scale factor. Then I have my x, my t, which is the 3. And I know that 6 times 3 is 18. So that checks out. Okay, where do you see a unit rate? So remember, unit rate is when the independent value is 1. So I want to know when the time is 1. So when the time is 1, I see it's at 0 at 1/6. So I know the 6 miles per hour. Okay, so I see it right here in my table. And I see it right here on my graph. And I see it right here in my equation. Okay. So where's the constant proportionality in the table? In the table, it's my row 2. Again, that would depend on how you set up your table. So table, my row 2, where the t is equal to 1 and the m is equal to 6. On the graph, again, it's at the point 1, 6. In the equation, it's the number in front of the independent variable. Coefficient of the independent That's just a lot of talking. Coefficient independent variable. Y is equal to, well, that's not y, it's m. M is equal to 6t. It's right here. This is 6. Okay. So I know that my unit rate is Tony's going 6 miles per hour. Okay, so in any situation, we always want to grab the unit rate however we can, because it's the most helpful to solve any kind of questions. Suppose another runner started at the same time as Tony and runs 3.5 hours and ran a distance of 20 miles. Who is going faster? How do you know? Okay, so I take the information that I already know. I know that Tony is cruising at 6 miles for 1 hour. And I don't like my mouse options. Classic. I like classic. Okay. And the other person, is going 3.5, is going, let's go the same way, 20 miles in 3.5 hours. I want to get a unit rate. So I want to know what is that in 1 hour. So I know to get from 3.5 to 1, I have to divide by 3.5. So up here on the 20, I have to divide by 3.5. So I know how fast they're going. All right. So 20 divided by 3.5 is, I'm rounding here. So I need to adjust this because it's not actually equals. It's about 5.71 miles an hour. So that's obviously slower. So Tony is faster. She covers more distance an hour. All right, new problem. Now, I don't know how to say this name, so we'll call her Sarah, but you might pronounce it a different way. Milo and Sarah each bought chocolate cinnamon bears from different candy stores. Milo paid $3 for 2 pounds, and Sarah paid $5.25 for 3 pounds. Assume the rates are proportional. Okay, so I put in the information that it gave me. It said Milo is paying $3 for 2 pounds. And Sarah is paying $5.25 for 3 pounds. Okay, and it said it's proportional. So because I know it's proportional, I know, 1, it goes to the origin. So I automatically know on both of these, if we didn't buy any candy, we don't have to pay any money. Okay, and then I want to go for the unit rates. I know that 2 times 150 gets me $3. So I know that the unit rate is 150. Over here, I'd have to multiply by 175 because 525 divided by 3 is 175. So I know that Sarah's paying $1.75 per pound. And then I could pick whatever I want after that. So whatever choice you want. I'm going to put 3 pounds, 4 pounds, but if you wanted a different number, you totally could. So 150 times 3 is 450. 4 times 150, or you add 150 on, is $6. Okay, so here, for 3 pounds, she's going to pay $5.25. And for 4 pounds, she would be paying $7. Okay, I'm going to be graphing my points, so I need to make sure that I label and that I am doing different colors for each person so I know which one's which. So our independent is pounds because when you go to a store, remember, you bring the food up and then you ask how much it is. You don't really take your money and say, go get me as much as you can. I guess you totally could, but that's not how we work in the world. Okay, so I'm going to go ahead and do Milo's points first. So they pay nothing for 0, and then 1 is 150, and 2 is $3, and 3 is 450. Again, this should be making a straight line. So if you get a curve, you know you did something wrong because you know you're supposed to be proportional. Okay. And hold shift down. That helps you make straight lines while you're using your Cami, because we don't want to be sloppy on our graphs because later on that will help hurt us if we are. And we like to label. That's Milo. Milo. And then whatever your other color is, I'm going with green. She's got something 0, 0 again. And then 1, 175, so kind of a little higher. And 2 is already off my graph at $7. Oh, I don't have a 2. Let's go back. We put the 3 twice. We can't put the 3 twice. Let's figure out what 2 would be. So 2 times 175, 350. There we go. Okay, so at 2, it's 350. And at 3, it's 525. Okay, and then we connect, holding the shift key down, making our nice line. Okay, and labeling it. Sarah's. Okay, unit rate. Remember, that's how much for 1 pound. So here it's $1.50 per pound. Rates need to be labeled. And over here, she is paying $1.75 per pound. Constant proportionality is the same thing, it's just not labeled. Here we're multiplying by $1.50. And here, why is that not turning to a dollar sign for me? Ooh, took it all the way out. Okay. This is 175. So obviously, this is cheaper. I'd rather pay $1.50 per pound than $1.75 per pound. So Milo has the better deal. Milo has the better deal. He pays less per pound. Okay, again on our graph, it's when our independent value is 1. So 1, 150. This one goes through 1, 175. This unit has a lot of repetition in it. Equation, we take that constant proportionality. So y is equal to 150 times x. Over here, we have y equals $1.75 times x. Okay, hit pause, catch up. So I should be able to give you a table and you can come up with the graph and the unit rate and the information, or I can give you a context, or I can give you a graph. No matter what starting point I give you, you should be able to come up with the other stuff. So in the next problem, they are giving us the graph and we've got to come up with the stuff. So I look at my points on my graph and I go, okay, I know it's not proportional. I'm looking at the graph, it's not proportional because it does not start at the origin. It's not starting down here. It's starting up here. So this is about a cab ride. I have to pay money for the person to drive to where I am so I can sit in the car and go nowhere. Okay, so there's a $4 charge for them to show up. And then once we start driving somewhere, I have to repeatedly increase the money I have to get charged. Okay, so but this is not proportional because it's starting, I want a brighter yellow, maybe let's go blue. It's starting at 0.4, and then for 1 mile, I get charged $5, 2 miles, $6, 3 miles, $7, 4 miles, $8. Again, these are just nice points. So I'm picking my points off my graph. 0.4, 1.5, 2.6, 3.7, 4.8. Okay, I know the miles because it's on the x-axis is the x, the first point in the coordinate, and this is the y, the cost. Okay, so this is my x part and this is my y part. So I had 0, 1, 2, 3, 4. My cost was 4, 5, 6, 7, 8. Okay, so this one, to go 0 miles, it costs $4. So the initial fee is $4. Okay, and then it starts giving me some prices. To go 1 mile, it costs $5. And now I'm going to repeat myself with just changing some little details. So I'm going to go ahead and control copy and paste and then just adjust things. Okay, so to go 2 miles, it costs it costs $6. To go 3 miles, it costs $7. To go 4 miles, it costs $8. Is the graph proportional? No, it does not go through origin. There is an additional fee. There's a starting fee of $4. And then it costs an additional $1 per mile. So there is a rate. It's just not a unit rate. It's not a unit rate because it doesn't start at 0, 0. Is there a unit rate? No, it's not proportional. Okay, so here we have a rate. It is $1 each mile you go up. It goes up $1. So it's $1 per mile. But you had to pay $4 to start. So there's an extra 4 on the end. Now we don't have to write the 1 in front of the x. It's implied. So we can just write y equals x plus 4. Okay, we get that because the cost is equal to $1 per mile plus an initial fee of $4. Okay, hit pause and catch up. All right, so here we know that the number in front of the x is the unit rate. So I don't know what this is about. Maybe it's about buying something. So this may be $1 per pound, where this is $1.50 per pound, and this is $3 per pound, and this is $2 per pound. So I know this is the cheapest one, and this would be the most expensive one. I know that none of them have anything added at the end, so they all go through the origin. Okay? So this is my x values, my x-axis, and this is my y-axis. And I need to graph these things. So my first line, I'm going to use blue for it. It's going to go through 0, 0. And then at 1 times 2 is 2, so it's going to go through 2, and then 4, and then 6, and then 8, 10, 12, 14, 16. And I'm going to go ahead and connect that. And label it, because I'm going to put more than one graph on it, y equals 2x. And then I'm going to pick a different color. Y equals 3/2 x. Okay, it's still starting at 0, 0. At 1, it's at 1.5. At 2, it's at 3. And then 4.5. And then 6. And then 7.5. And then 9. And then 10.5. And then 12. And then 13.5. And then 15. And I'm going to label that. Connect it, holding my shift key, label it. Y equals 3/2 x. Pick a new color. Y equals 1x. It starts at 0, 0. And it goes to 1. And then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Y equals 1x, or just y equals x, same thing. Then a new color, purple. Okay, y equals 3x. It starts at 0, 0, and then it goes to 3, and then 6, and then 9, and then 12, and then 15. Y equals 3x. So I see the bigger the coefficient, the constant proportionality, the unit rate, the steeper the graph is. Okay, so here we knew when x was 1, we got our constant proportionality. So this one was a 2, and this was a 3/2, and this was a 1, and this was a 3. The proportional constant controls the steepness of the graph. The bigger the steepness, the constant of proportionality, or the proportional constant, same thing. Controls the steepness of the graph. The higher the coefficient, the steeper the graph. Okay, hit pause, catch up. All right, you might want to try the next one on your own and then see if you get it right. Okay, fill in the missing amount of quarts in gallons, then find the ratio of the number of quarts to the number of gallons. So we have to know for this problem that there are 4 quarts in a gallon. We can see that because 2 times 4 is 8. So we can see it right from here. I started with looking at my rate. I'm assuming it's proportional because that's all we're really doing right now. And I noticed that, oh, I can multiply by 4 to go that way. Or to go the other way, I would multiply by 1/4 or divide by 4. So 1 times 4 is 4, and 4 times 4 is 16, and so on. I'm plugging in. Here I have to go backwards. 80 divided by 4, or 80 times 1/4 is 20. 180 divided by 4 is 45. This would be 400. I know every time I'm multiplying by x, so this is by 4, so this is 4x. And I do my ratios. 4 over 1 is equal to 4. 8 over 2 is equal to 4. I'm going to see that all my ratios, because it's proportional, reduce down to 4. Even 4x over 4 over x reduces down to 4. So what does the y over x ratio tell us? Because it's the same, it tells us it's proportional. Okay, write an equation. Show the number of quarts to the number of gallons. We know that if we want a gallon, if we want a quart, we have to do 4 times the gallons. Okay, so here, honestly, it doesn't matter which one you put as independent and dependent, but the way we wrote our equation, our gallons would go down here and our quarts would go over here. So if I have 0 gallons, I have 0 quarts. If I have 1, I have 1 gallon, 4 quarts. And then 2 gets me to 8. Now, I don't have to do a whole lot of points. I technically only need 2 to get to a line, but I'll go to 7. 7 would be at 28. So I can easily make a straight line. If I don't have very many points, it's hard to make a straight line. Okay, so describe how you move. When I go up 1 gallon, I increase to 4 quarts. I'm going to fix that line. I don't like it. It was good. There it goes. It like shifted on me. Okay. Move right 1 gallon. You must move up 4 quarts. How does this movie relate to the rate? It is the same as the rate. Excuse me, 4 quarts per gallon. Okay, with the order pair, so 6 times 4 is not 26, so no. How would your ratio change if quarts became the independent? Well, then I would just flip it over. It'd be 1/4 of a gallon per quart. Remember, the different unit rates are reciprocals of each other. The new equation would be a quart is equal to 1/4 of a gallon. So we're going to get a flatter line. So if this over here becomes my gallons, my quarts, sorry, and this becomes my gallons, I'm still going to be proportional. But I have to go to 4 quarts to get 1 gallon, so I'm down low. I have to go to 12 quarts to get 3 gallons. And we'll go to 28. 28 quarts to get 7 gallons. 1, 2, 3, 4, 5, 6, 7. So it's a lot less steep. It's flatter. The second graph is flatter. Okay, that is it for the lesson. Hit save, and then you can go and tackle the homework.